Our phones need power to operate. And our goal as voice over IP admins is to deliver that power in the best possible way. Of course, you know the title of this nugget. I'm after power over Ethernet, where our switches deliver power over the Ethernet cabling. Now, as an honorable mention, I'll mention these two as well. You saw it in the last nugget, a picture of one. They have inline couplers that you can use to inject. Maybe you have just a deployment of a couple phones. You're doing like a test, and you don't want to upgrade your switches yet. Oh yeah, those work just great. Or those onesie, twosie devices out there that need the power. They also create power patch panels where you can put an entire patch panel in between the switches and deliver power down the line. But I mean, I checked the price out. I was like, man, that'd be probably a much cheaper way. I mean, I think the cheapest I saw these was like $500 for 24 ports. I'm like, good grief, you might as well just upgrade the switch. And then you have the power bricks. You can purchase the power bricks individually for the IP phones. Careful if you think that's a cheaper way, because those things run, I'd say $20 to $30 a piece. The phones don't come with the power brick, so you start adding up the cost of all those, and again, it puts you in that same, probably not all the way there, but almost to the point of buying the new switch anyway. So as you know, the focus of this nugget is power over Ethernet. There are three methods that a Cisco switch can use, depending on the model of switch, to deliver power over Ethernet. The first is Cisco pre-standard. Cisco was first to the game with power over Ethernet, and before there was an industry standard PoE out there, Cisco created their own. It was called Cisco Inline Power, and it worked well for years. It actually got up to 10 watts maximum of power that it could deliver. It would do it by sending something called an FLP. Fast link pulse. It was actually, it like toned the cable. So you'd have the switch, let's say you use this guy down here, you'd plug in the phone and it would send a little tone down the cable. And if it was a Cisco inline power device, it would loop that tone back to where the switch would go, oh, okay, you're an unpowered device. Let me send electricity down the line and turn that phone on. Now, the switches use the opposite set of pins. So inside of a cable, there are 8 individual wires. If you were to take a cable and splice it all up, you have 8 individual wires. Some are used for data, and that's going to be 4 individual pins or 2 pairs. The opposite set of pairs are used for power over Ethernet. So that's the ones that the power goes over. Now, as the industry caught up to what Cisco did, they came out with Cisco, or not Cisco, but 802.3 AF. That's the industry standard power over Ethernet. I would say this is the standard today. That everybody's like, okay, when you say PoE, that's today, and I'm talking 2013. What people are thinking about when you talk about 802.3 or when you talk about power over Ethernet, it's 15.4 watts per port, which is it's a good standard. It powers almost all devices that you know most consumers use, such as phones, such as wireless access points, such as video cameras. However, it does. I mean, some of them need a little bit more power than that. You know, some video cameras have a little base that allows you to go, you know, kind of focus it in different directions. Some phones support advanced capabilities where they need some more power. And so this standard, and I would say this is, again, 2013, so, you know, it'll probably be more permeated as time goes on. This standard ups it to 25.5 watts of power that you can use. And some vendors are even tweaking it and making their own little proprietary flavors, kind of doubling up on the pins, and getting 50 watts of power, which to me, that's really exciting because I'm thinking, okay, not only that powers every IP phone, and I mean, that's now a no-brainer to power all major devices, but I start thinking about, okay, you know, cloud computing. Everybody's like, oh, go to the cloud. And one of the big things is now you've got these thin clients, you know, to where it's just a monitor and a mini device that is really just a fancy video card that displays a remote server console. I'm thinking, man, you could probably create devices, if they're not already out there, they may be, that uses this standard, and you run an Ethernet cable to the monitor, and maybe the monitor has a little coupler where you connect that to the device, and now you have terminals that you can actually put all around your network where you don't need to plug in. And it's not just a convenience like, oh wow, now we don't need plugs, but I'm also thinking about centralized backup to where you get a big old UPS power supply that's powering these guys. The lights go dark, the computers and the phone system. I mean, it's all, the phone system has always been like, okay, we've got something there, but the computers themselves keep running. I mean, that's cool. That's where things are going. Now let me throw out one recommendation. If you're looking for a great lab switch, oh man, this switch is amazing. Cisco 3550 inline power switch. I actually just pulled it up on eBay. I mean, you could probably even get it cheaper, but buy it now for 98 bucks. You've got inline power, and now it's a 100 meg switch. Okay, it's not gigabit. It's a lab switch, right? So you've got power over Ethernet that this thing supports. It's also a layer 3 switch. Just to give you an idea, back when I was preparing the CCIE series for CBT Nuggets, I bought two of these. This was back in 2004, and I paid $1,100 used for these. So I mean, if you're just looking for a quick little lab to set these up and play around with and set up your own little voice over IP world, I can't recommend a better switch than this. This is just a great switch. This is a Cisco 3550 switch that we're on right now. I'm going to do a show CDP neighbors just to show you. I just grabbed one of the phones. Now I can see device ID, SEP, and then the MAC address of the device. By the way, that's the default name of just about every Cisco IP phone you'll pull out of the box. Most people, random side note, most people don't know what SEP stands for. It's actually Cisco's throwback to the company they acquired long ago. It's funny that they've never changed it. It's like they want to honor the company. Celsius Ethernet phone. Now, Celsius, not spelled with a C, spelled with an S, is the company that they originally acquired. I'm going to do a show CDP neighbors detail, and you can see that this is a 7970 IP phone. I can see, the version of software it's running, all that. The big thing relevant to this nugget is take a look at this. Power drawn 10.25 watts. Now, normal, I would say, general phones. Now, this is a 7970 backlight, full color display. 10 watts is a pretty good chunk of wattage. Usually you'll see phones consuming in the range of 7 to 8 watts of power. I can also do a show power inline. And you're able to see here that we've got a Cisco 7970 IP phone. Shows a max. Again, we're looking at the standard 802.3 AF, 15.4 watts. There it is. But this guy has negotiated down to 10.3. I want to show you something. Watch this. I'm going to go into the individual interface. Let's do interface fast Ethernet 0/9. I'm going to first off say power inline. You can see that there's an option. We can say I want to automatically detect, which is the default on every single switch. Or I can say I never want to apply power on this port. That is useful because there are some times where you buy a switch where there's not enough in the power supply to power all the ports, and it will prefer the lower port numbers. So you might say, well, I've got a device plugged into port 20, but ports 1 through 12 are consuming all the power, or again, however much is allocated to that switch. So I want to turn it on never for those low ports so that I can get the power on the high ports. Some of the switch ports will do that. Now, obviously, there's no on here, right? Because you don't want to fry devices. You don't just want to turn on the power. This is, fry people as they plug in. And then there's the delay. You can delay the power over Ethernet. So you can tweak it that way. But what I wanted to show you is this. I'm going to shut down the port. And I'm looking at the phone beside me. It just shut off. And I'm going to do a no shut. And okay, the lights are blinking on the phone. Now I'm going to do a show power inline. Watch this. Notice right here, it's showing 15.4 watts is actually in use. I'll hit the up arrow again. It's saying, okay, right now the device is an IEEE PD. I don't know, Police Department Power Detect. I don't know what the PD stands for, but essentially it's saying this is an industry standard device. It's something using the IEEE PoE standard. And right now I'm allocating 15.4 watts. What happens is the switch negotiates with the device using, drumroll please, Cisco Discovery Protocol. So it's going to negotiate and say, hi device, how are you? Device is like, I'm good. Oh, thanks for this 15 watts. It's very tasty. However, I only need 10. And the switch will reduce itself down to whatever value it negotiates. Now, some of you might be thinking, okay, CDP to detect the power, right? So what does that mean if I plug in a heathen phone to where it's not running CDP to be able to negotiate with the other side? Well, what may happen is the switch may not be able to tell how much power is actually being consumed, and it will provision the full 15.4 watts for that port. That doesn't mean it's going to cook the phone. Don't worry about that, because the device will be like, oh, well, I don't need that power, so it's just going there wasted. But a lot of times Cisco will spec out the power supply that it's not really providing the 15.4 watts on all the ports. It knows, the average is about 7 to 8 watts per port that is being consumed. So Cisco only puts a power supply in that may consume that amount. So what may happen is if you use these non-Cisco devices, you may end up with a shortage. Like you get to port 18 or something, and it's like, oh, I'm out of power. Sorry. So you may have to look online. Cisco has a command where you can, that same power inline auto, the 3550 doesn't support it, but it's power inline auto, and then you can type in the maximum wattage that is allowed on that port. Again, it's just one more manual configuration step that you'll have to take above and beyond. Well, there's not too much more to power over Ethernet. It's just one of those things that happens. Most people don't even know there's commands they can use to verify power over Ethernet because it's so brainless, it's just running behind the scenes. Well, I hope this has been informative for you, and I'd like to thank you for viewing.